today we are discussing about the imperfection of solid. Imperfection of solid is very important, that belongs to the topic of solid state, that is imperfection of solids. That is imperfection of solid. So first of all, we should understand what do you mean by imperfection. Imperfection means any kind of the deviation in a perfectly ordered crystal. Any kind of the deviation in a perfectly or regularly arranged crystal is known as imperfection. The two types of imperfection in solids, mainly the two types of imperfection in solid. One is the Fringle defect, another one is the Schottky defect. And it's a Schottky defect. Another is Fringle defect. The Schottky defect is also known as vacancy defect. Also known as vacancy defect, and Fringle defect is also known as interstitial defect. That is known as interstitial. Fringle defect is also known as the interstitial defect. The vacancy defect means the equal number of the anions and cations missing from their on lattice sites. The interstitial defect means the cations are leave from their normal sites and they occupy in an interstitial position. That cations or anions they leave from their normal site or normal position and they occupy an interstitial position or interstitial site. This is known as the interstitial defect. And in the case of the Schottky defect, the density of the crystal is decreases. That means the equal number of the anions or cations are missing, so that the resultant, that is the density, decreases. The density decreases in the case of the Schottky defect, but in the case of the Fringle defect, the density remains same. But in the case of the Fringle defect, that is density remains same. And also the Schottky defect, which is showing high coordination number ionic compound. The Schottky defect which is showing high coordination number ionic compound, and the Fringle defect which is showing the low coordination number ionic compound. In the case of the Schottky defect, the anions and cations are equal size, but in the case of the Fringle defect, the size of the anion and cations are dissimilar. In the case of the cation, the size of the cation is very smaller when compared to the anion. And also in the case of the Schottky defect, showing the compounds such as the silver bromide and the sodium chloride and potassium chloride and the cesium chloride are the example of the Schottky defect showing compounds. And the Fringle defect, that is silver chloride, silver bromide and silver iodide compound with, and also that is zinc sulfide. Such crystals are showing Fringle defect. And the case of the silver bromide and the silver bromide is showing both Schottky defect and Fringle defect. The silver bromide which is showing the both Schottky defect and the Fringle defect. And another important concept is the density. In the case of the Schottky defect, the density is decreases, and in the case of the Fringle defect, the density remains same. That's a very important concept, and we should, very simple concept. This is very simple concept. Also, this kind of the question is very important in the case of the competitive examination and other our theory examination point of view. This concept is very important. That is, imperfection of solids is a very important concept in the case of solids. Thank you to all.